Okay, hi Year 9. Welcome to your weekly introduction videos where we're going to be looking at the surface area of prisms. So we've looked at how to calculate the volume of prisms last week. What we also need to be able to do is calculate the surface area of prisms. Now this is a topic that students find hard, and I have no idea why. It's really easy, okay? If you just think about what you're doing, surface area is just all the areas of the faces of a 3D shape added together. So all you've got to do is count the number of faces and then make sure that you find out the area of each one and just add them together. Now, I just want to be absolutely sure that you can do it with a cuboid. You know, we've already looked at cuboids in the last couple of weeks, but let's just check you can do this. Well, actually, I'll go through it. So what is the surface area of this cuboid? Well, it's got 6 faces. It's got one face here, another face that's the same round the back, so I'm talking about here, a face at the front and a face at the back. Okay, so a face at the front and then a face round the back and a face at the top and a face at the bottom. And because it's a cuboid, a lot of these faces are actually the same. So face 1 is it's a rectangle. So it's 9 times 5, which is 45. And face 2 is actually exactly the same. Okay? Otherwise it wouldn't be a cuboid. Face 3, which is the one at the front, has a base of 4 and a height of 9. It's a rectangle again, so that's 36, and rectangle 4 is exactly the same. Rectangle 5 is also a rectangle, not a square, because it's not 4 times 4 or 5 times 5, it's 4 times 5. Base of 4, height of 5, giving me 20, and so is rectangle 6, exactly the same. So all I've got to do is add them together. So that's 90 plus 40, 130, 190, 202. I think if we add all of them up, that'll be 202 centimetres squared. Okay, so be very careful. That obviously was immediately wrong because it's an area, so it should be centimetres squared. So actually, this is the correct answer. 202 centimetres squared. Okay, so you need to be able to do that. Now, just before we move on from this question, I just want to make sure that you understand that maybe this is an open box. An open box. Well, what does that mean if it's an open box? What it means is there's no lid. So if there was no lid, it would mean you wouldn't count this one because it isn't there, it doesn't exist. So maybe what I would ask you for is the external surface area of an open box. But if that's the case, now you only have 5 faces to worry about. This top one here doesn't exist because it's an open box. So make sure you read the questions carefully and look out for little things like that. Okay? Right, so here's 3 for you to do. Just check you can do them. Find the surface area of each one. Okay, hopefully you've done that. There's the answers. If you're not sure, you better ask, okay? You guys are too afraid to ask sometimes. Right, now, here's a prism. And what we've got to do is find out the surface area of this prism. It's getting tricky now because we've no longer got a straightforward shape. We've got to think, how many faces are there? Well, there's a triangle at the front there and a triangle at the back. And then actually what there are 3 rectangles. So there's a rectangle at the back there, a rectangle at the bottom there, and this sort of slanting rectangle here. So I've got 3 rectangles and a triangle. Okay? Now, let's first of all find out the area of the triangle. Well, area of a triangle is base times height. Well, I've got a base of 5 and a perpendicular height of 12. So it's going to be 5 times 12, and don't forget to divide it by 2. It's a triangle. How many times do I have to remind you guys of that? So triangle 1 has an area of 30, and because it's a prism, so there's a cross section, the triangle 2 is exactly the same. Okay, so I don't have to do too much work there. That's also 30. Okay, now 3 is a rectangle. Let's just have a look at it. 3 is a rectangle. I'm talking about this rectangle here. Got to think 3D. Now, what is the base and what is the height of that rectangle? Hopefully it should be obvious that the height of it is 12 and the base of it is 11. Okay, so that's going to be what, 132 centimetres squared. Notice I don't need to bother with units until the end. Now, rectangle 4, that's this rectangle here that I'm doing in green. Okay, has a base of 5 and a height of 11. Or the other way around, doesn't really matter. So 5 times 11 is equal to 55. Now, there's one more rectangle to count, which I'm highlighting in yellow. It's this rectangle here. Now, you'll notice here, well, I know the base is 11, but what is the height? What is the height of this rectangle? Well, I don't really know at the moment, it doesn't tell me, but I should be able to work it out. How can I work it out? Well, I know this is a right angled triangle, and I know 2 sides of that right angled triangle, so I can use Pythagoras' theorem. So let's call this x, then we should know from Pythagoras' theorem that the hypotenuse squared, x squared, is equal to 12 squared plus 5 squared. So we have to use Pythagoras. I could have made this question easier by telling you that what x was, but I decided not to. You need to remind yourself about Pythagoras. So 12 squared plus 5 squared is equal to 169. Square root the answer, and that is 13. So this distance is 13. So I now know that the yellow rectangle has a base of 11 and a height of 13. So that would be 143. Now to find the surface area, all I have to do is just add everything together. So 30 plus 30, that's two of my faces, plus 132 is a third face, plus 55 is a fourth face, plus 143 is the fifth face. So that's going to be, the final answer is 390 centimetres squared, because it's an area, not cubed, not a volume anymore, it's squared. You know, you can now tell me what that is in millimetres squared or metres squared. Remember what the conversions are, okay? Right, if you're not sure about that, let me know. I'm going to stop the video there.